Charge is a fictitious charge. Okay, it's it's defined as the apparent charge that the atom acquires by being part of the molecule. So it's you can formal charge here, Fc is equal to F minus A. Here, F is the number of valence electrons that a free atom would have if it were alone. For example, carbon, for carbon, F is equal to 4. By itself, a neutral carbon atom would have 4 valence electrons. Fluorine, F is going to be equal to 7. Okay? A is the apparent number of electrons that the valence electrons that the atom owns in the structure. So it's the number of electrons that the atom appears to own. That's why I'm using the letter A there in the structure. We're assuming here, for the purposes of calculating formal charges, we assume that an atom owns all the electrons in its lone pairs, but only half of the electrons that it is sharing. Okay? And one quick check you can do after you've done calculated formal charges is to add them all up. They make sure that they all add up to whatever the overall charge of the structure. So if you have a molecule, all the formal charges in the structure you drew should add up to 0. If you have a polyatomic ion, they should add up to whatever the charge of the polyatomic ion is. So let's figure out the formal charges for the atoms in this structure that's drawn over here. So let's start with sulfur. Okay, a free atom of sulfur. Okay, it's column 6. So for sulfur, F equals 6. In this structure, it appears to own how many? Well, let's see. It appears to own 2 in its lone pair. And you have 3 pairs here. Half of 3 pairs would be 3, right? 3 singles. So 2 plus 3 would be 5. So F minus A would be 6 minus 5 would be plus 1. Okay? A free sulfur atom, we say, has 6 valence electrons. It appears to own only 5. So by being part of this molecule, the way this is drawn, you're making it appear that sulfur has lost an electron, so it has a formal charge of plus 1. So formal charge of sulfur here is plus 1. You might indicate that with just a plus on there. Okay? What about carbon? Let's look at the formal charge of carbon here. Carbon by itself, okay, a free carbon atom, group 4A. So a free carbon atom would have 4 valence electrons. Okay, how much does it appear to own in this structure? Well, half, it's got 1, 2, 3 pairs, 4 pairs. Half of those are all shared, 4 bonding pairs. So half of 4 bonding pairs is 4 singles. So that appears to own 4. It doesn't have any lone pair. So 4 minus 4 is 0. So the formal charge of carbon there is 0. Okay? And 0 right here. And oxygen. Let's take a look at oxygen. A free atom of oxygen by itself. Okay, it's group 6A, so an oxygen by itself would own 6 valence electrons. In this structure, it appears to own 2, 4, 6. All the electrons in the lone pairs belong to that oxygen. So 6 in the lone pairs, 3 lone pairs times 2, plus half of this pair right here. So half of one pair is 1 single, so plus 1. So that it appears to own 7. So 6 minus 7 is equal to -1. So it appears the oxygen has gained 1 electron. So it has a formal charge, we say, of -1. So you can put a -1 over here, or just a negative symbol right there. So those are the formal charges of sulfur, carbon, and oxygen in this structure.